Hi guys, in this video what we're going to do is we're going to talk about degrees and another way of measuring angles, which is what's called a radian measure. Okay, so what is a radian measure, or a rad for short? We look at this circle here. You can see this is just a general circle, and you can see from the center we have a radius heading out in this direction here, but we also have another radius heading in that direction here, which is of length r. Now, what you'll also notice here on the diagram is that this arc here is the same length as the radius here and here, and that essentially makes 1 radian. So 1 radian is defined to be the angle in the sector of the circle, so this angle here, when the arc length r is equal to the radius of the circle. Now this definition holds no matter what size the circle is, and if you actually calculate this into degrees, 1 radian is approximately 57 degrees, so roughly 57 degrees. So I want to go and have a look at something else here. You can see here that what we have, if we look at the circumference here, the whole circumference here is given by 2 pi r, where this 2 pi is a constant because pi is just 3.14 blah blah blah. Okay, the things that we can change in a circle is we generally change the radius, and if we increase the radius or decrease the radius, this will either increase or decrease the circumference. So this 2 pi is a constant, and if you think about it, what we have here is that if we are trying to find out how many r's are into the circumference here, we know that the circumference is 2 pi r, and if we divide it by r, which is this length here of the arc, then what we end up with is 2 pi, and 2 pi is the angle in radians of this full circle. Well, if it's the angle, we also know that the full angle of a circle in degrees is 360 degrees, which means that 2 pi radians is equal to 360 degrees. We can further simplify that obviously by dividing by 2 both sides of this relationship, so we now know that pi radians is equal to 180 degrees, and that gives us a conversion between radians and degrees. Now you're probably wondering, why do we use radians instead of degrees? Well, it's just much more useful when it comes to calculus, and it holds for every single circle. Okay, let's have a look at how we're going to use this later to convert from degrees to radians and radians to degrees. Okay, so you can see here that I've got a couple examples. I'm just going to do a few. This shouldn't be too difficult for you. What we have here, we're going to convert to radians from degrees, and then we're going to do the opposite over here. So let's have a look at the first one. So you can see here it says convert to radians 90 degrees. So the first thing we do is we know that 180 degrees is equal to pi of the radians. Okay, you can put an r there for rads if you wish. And what we're trying to do is we're trying to get to 90. Remember, everything is in ratio. So how do I get from 90? Well, if I'm going from 180 to 90, what I'm doing is I'm dividing by 2. Whatever I do to the left-hand side of this equal sign, I'm going to do to the right-hand side of the equal sign. And what you can see here is I'm going to end up with now pi divided by 2. And it's as simple as that, boys. All you're doing is working out how you get from one to the other and doing it on the other side. So let's have a look at II. Okay, so here what we have is we're trying to get 150 degrees. So again, we start with 180 degrees is equal to pi radians. Okay, now how do I get to 150? That's the question you've got to ask yourself. So let's have a look here. What we could do if you wanted, we could find 1 degree, and that's easy enough. So let's do that. So we can see that 1 degree here is equal to, well, how do we get from 180 to 1? We divided by 180, which means we're going to do exactly the same on the other side. If we do that, we get pi divided by 180 rads. Okay, I don't want 1 degree, I want 150 degrees, so let's underneath that we'll write 150 degrees is equal to, Well, okay, how did we get from 1 degree here to 150? Well, we multiplied by 150, which means that we have to do exactly the same on the other side. That now means my new fraction in terms of pi is going to be 150 pi over 180. And that means now that we can actually simplify that and divide both top and bottom by 30. And we can see that 150 degrees is equal to, divide both by 30, you get 5 over 6 pi. So 5 pi over 6. And we're done. Okay, so we've done from degrees to radians. Let's do it the other way around. So the first one here, we have 3/4 pi. What's that in degrees? Again, what we do, guys, is start off with pi is equal to 180. And what we want now is we want 3/4 pi on this side over here. So what did we do? Well, very straightforward. We multiplied by 3/4, which means that we've got to do exactly the same on the other side. So multiply by 3/4. And if we do that, 180 multiplied by 3/4 is 180 divided by 4, which is 45. 45 times 3, which is 135 degrees. The second one, alright, same sort of idea. We start with a pi is equal to 180 degrees, so pi rads is equal to 180 degrees. And this time we want 7 over 6 pi. Okay, so 7/6 pi, not an issue. How did we get there? Well, we multiplied by 7 over 6. So we must do exactly the same on the other side. And 180 times 7 over 6, you need to calculate if you want, boys, makes no difference. But what you'll see is 180 divided by 6 is 30. 30 times 7 is 210 degrees, and we are done. The most important thing to remember when changing from radians to degrees is the fact that pi radians is equal to 180 degrees. Once we have that, you can see from here, here, and here, then we can work out anything that we want.